want to know what you can plug in, you grab the manual for the Solarc 5K. It's 70 pages. Nobody ever reads them. Read it. You'll go to the section that says photovoltaics, and it's going to tell you what inputs this inverter can take in terms of PV. It will tell you what the total array size is from the sum of all arrays. That includes this 1 kilowatt here. It's going to tell you what the maximum voltage can be, what the minimum voltage should be, okay, and how much current can go into each connection. So what you'll find is, if you look it up, is that any single string can have up to a 20 amp circuit on it and can't exceed 500 volts. So I would tell you shouldn't exceed 450. Because unlike what most people think, when it's cold and clear, the voltage can go up dramatically, and so can the current, and the module can exceed its published capacity. Because when you see a solar module and it says this solar module is good for 300 watts, okay, that's at standard test condition, and that standard test condition is with a light source that has an energy strength of 1,000 watts per square meter. They actually create these light sources. They're calibrated 1,000 watts per square meter. They have a certain pattern of wavelengths that kind of emulates the sun. It's not identical, but emulates the sun. And then if they pass that 300 watt test with 1,000 watts per meter squared, which can happen on a clear day, then they pass, and they pass that 300 watt module test, or 400 or 500 or whatever it is, whatever the label says on the back of the module. On a cold day, the power could go higher. Both the current could be higher. Not likely the voltage, but the voltage can be higher too. It will go up. And the rate it goes up is actually on the sticker too. So if you look at the sticker here, it's going to tell you that where does it say? You can see the VOC, open circuit voltage, short circuit current, VMP, minimum fuse size, maximum fuse size 15 amps. On this, it's 20 amps. But the data I was looking for isn't here. And what we're looking for, so you'd have to pull up this module type, Google it, and we would see that there's a temperature correction factor. And you would see the number that you use for every degree centigrade below and above the test condition. What happens to the voltage and what happens to the current. All of those things have to be known. So once you know what the module is, and you don't want to put dissimilar modules in the string, because these don't have optimizers. These are called optimizers. We don't have optimizers. Each optimizer costs $60, $70. So we're trying to avoid those costs. The optimizers allow you to use dissimilar modules, okay, and still put them in the same string. Having said that, we're not using optimizers. You won't see those. You just see the junction box. We want to use the same modules at the same pitch, at the same azimuth or direction, in the same string. So any string should have the same pitch and the same azimuth. Okay, so all the modules behave the same. So then we put them in series. The voltages will add. So whatever this voltage is here, if you looked at the VMP, the voltage at its maximum power point, so it'll say VMP or something like that. It's probably around
VOC,
60. VOC is open circuit voltage. That's different. So you're looking for V at maximum power. So
VP max.
There we go.
58.
So this is creating 58 volts at its maximum power. And 58 and 58 and 58 is 150 and 24. So there you go.
174.
174. But the other day I measured 190. Put my voltmeter on here and I got 190. Well, how could that be? If it's its maximum power, it's because it was cold in the morning. It's 52 degrees. And these are tested at, I think, 20 centigrade, which is somewhere around 70. So they were outputting a higher voltage than the V max. So normally what I do is, if the inverter says I don't want more than certain voltage, 500 volts, I look at the VOC. The VOC is the open circuit voltage. You'll see that on there. That's always higher than the VMP, or V maximum power point. And then for every module you put in that series, you have to add that
That's
again.
69.7.
So let's call it 70 for fun. So if I don't want to go over 450 and I round down, what would I do? Well, 450 divided by 70, 6, right? It's gonna be
So 6
420.
modules. Right, so you'd be able to do one more
So I
replication
could
of
do
this.
6 modules. I could do 3 more in this series, and I wouldn't violate what the inverter input is saying. I could do 6 more. So,
Or you could do them in parallel,
or we could do another string.
as long as the current
So we'd
isn't
have to create
exceeded.
another circuit, so we'd have to put 2 more plugs in, which is no problem. I didn't do it this time because I didn't want plugs sticking out here because I didn't know where this box was going to go, and I don't want someone breaking anything off the side.
Yeah.
And I had to get all my connections downstream of the inverter, which is sitting here, because I didn't want any of these penetrations where the inverter was. So I jammed as much as I could into
Yeah.
the space that's sitting to the south or below the inverter interconnection. So all these connections are coming out of here and curling into the inverter. And then when you're designing it so it looks nice and neat and clean like it does, you got to know, okay, what's here? Oh, I put the loads at this end. Why did I put the loads at this end? Because the first connection is the loads. So then I could have
Right.
a little arc
It goes
and that
around.
minimize the amount of wire. And then
Very
what's my
good
next
design.
connection on the inverter is the generator. So to minimize that amount of wire and make it look nice and neat with a nice little arc, that
Good
arc's
generate.
and so and so. So you see so many designs today where aesthetics, people don't pay attention to aesthetics, and it means everything. If you've ever opened up something and it looks like a spaghetti monster inside, you automatically jump to the conclusion that the person who built it was scatterbrained. And you might be right. It might be great, it might perform better than what you just built, but the world believes and the world perceives that it's a piece of junk. So don't do that. So aesthetics are very important, right? That's why we put labels on this. I think it would be a huge mistake not to have. I think the labels that we've bought, the decals, are just as important as the system.
They have a good
Because
value.
take Elizabeth Moore away from Elizabeth Moore's project, and it's not as meaningful to her, right?
Right.
Take USF away from USF's project, it's not as meaningful to her. Take TH out of his book that he just showed me, and he's not so apt to show me the book. Okay, so name recognition is huge. I would just say I've been working in project management for long enough to know that there are some things that are just as important, equal as important as what you're doing. You know, it's how you present what you're doing. Anyway, that's it.
Very cool.
Any